Visual a slow, cinematic shot of the solar system. The sun glows. Planets orbit in graceful, synchronized motion, soft, swelling music. You've been told that the universe is elegant, predictable, that if you just apply Newton's laws, sprinkle in some gravity, maybe a little thermodynamics, everything makes sense. Planets form from spinning disks of gas. They inherit that spin. They rotate in the same direction they orbit. Neat, orderly, logical sip. And then there's Venus. Illusory. Zoom in on Venus. The planet rotates slowly, but backwards. A subtle record scratch sound. Venus rotates backwards, not a little backwards. On Venus, the sun rises in the west and sets in the east. Rises in the west and sets in the east. And here's the part that should make you uncomfortable. Nobody can explain it with confidence. We have theories, we have simulations, we have elegant mathematical stories, but none of them carry the inevitability of gravity pulling an apple down. And that's where Richard Feynman would raise an eyebrow, because Feynman had a warning: if you think you understand nature without checking it against reality, you're fooling yourself. And nature cannot be fooled. So tonight, I want to take you on a journey, not just to Venus, but into the foundations of physics, into probability, into chaos, into the microscopic world of atoms. Because Venus rotating backwards isn't just a planetary curiosity. It's a crack in our intuition. And that crack is where the wonder lives, of Mizzioli's swirling protoplanetary disk around a young star. Let's start from the beginning. 4.5 billion years ago, our sun formed from a collapsing cloud of gas. As it collapsed, it spun faster, just like a figure skater pulling in her arms. Angular momentum, one of the deepest conservation laws in physics. If something is spinning and there's no external torque, it keeps spinning. You cannot just decide to spin the other way. The laws of physics say no. The collapsing cloud flattened into a disk. From that disk, planets formed, and they inherited that spin. That's why Earth rotates the same direction it orbits. That's why Mars does. Jupiter, Saturn. It's not an accident. It's physics, so Venus should too. But it doesn't. Visual split screen of Earth spinning rapidly, and Venus spinning extremely slowly in reverse. Earth takes 24 hours to rotate. Venus takes 243 Earth days. And it rotates backwards. If you stood on Venus, ignoring for a moment the 470 degrees Celsius surface temperature and sulfuric acid clouds, the sun would crawl across the sky in reverse and painfully slowly. So what happened? Let's test some ideas. First idea, maybe something hit it. That sounds reasonable, right? We believe a Mars-sized object hit Earth and formed the moon, so maybe Venus got smacked hard enough to flip it. But think about that. Flipping an entire planet isn't like knocking over a bowling pin. Isn't like knocking over a bowling pin. If visual a bowling ball spinning on a table, if a bowling ball is spinning clockwise and you want it to spin counterclockwise, you don't just tap it. You must deliver enough angular momentum in the opposite direction to cancel the original spin and then exceed it. That requires a colossal impact. Not just big, perfectly timed, perfectly angled. And here's the problem. Venus's rotation is incredibly slow. If a giant impact flipped it, why didn't it leave it spinning rapidly in the opposite direction? Instead, Venus rotates in reverse and barely at all. That's strange. Second idea, tidal forces from the sun. The sun's gravity pulls on Venus. Over billions of years, that gravitational tug can act like a brake. It can slow rotation. We see this with our moon. It's tidally locked to Earth. But tidal forces don't usually reverse direction. They damp motion. They reduce energy. They push systems toward equilibrium. Reversing spin requires passing through zero angular momentum. And that's not trivial. So maybe, just maybe, Venus didn't need a single dramatic event. Maybe it needed something subtler. Now we're entering Feynman territory. Visual zoom into atoms vibrating inside a gas cloud. At the microscopic level, nature doesn't have intentions. Atoms collide. They scatter. They move according to simple rules, Newton's laws, quantum mechanics. But when you zoom out, you see patterns. And those patterns are governed by probability. Let me ask you something. Have you ever seen a shattered glass spontaneously reassemble itself? Of course not. But the microscopic laws don't forbid it. Every atom in the glass follows reversible equations. Every atom in the glass follows reversible equations. If you reversed all velocities perfectly, The glass would reassemble the velocities perfectly. The glass would reassemble. So why doesn't it happen? Because probability says no. There are vastly more disordered arrangements than ordered ones. This is entropy. Visual. Simulation of early Venus covered in thick atmosphere. Venus has an atmosphere 90 times thicker than Earth's. It's like being a kilometer underwater. That thick atmosphere doesn't just sit there, it moves. It circulates. It creates enormous thermal tides as sunlight heats one side. Imagine blowing across a spinning top. Gently, constantly, for millions of years. You don't need one catastrophic shove. You need persistent torque. Over billions of years, atmospheric tides could have slowed Venus down, and in the chaotic dance of fluctuations, tiny variations in direction, the rotation might have drifted through zero and into reverse. Not because the universe wanted it to fit, but because probability allowed it. Here's an analogy. Imagine a coin spinning on a table. Bit visual, a coin spinning on a table, but fission slows it, it wobbles. Tiny imperfections in the table matter. Eventually, it collapses. Now imagine that instead of stopping, the table itself has microscopic vibrations. Random nudges of over a long enough time, those nudges might push the coin slightly backward before it settles. Venus may have been that coin, a planet caught between tidal breaking and atmospheric chaos. And here's where it gets profound. At the microscopic level, every molecule in Venus's atmosphere obeys simple, time-symmetric laws. But at the macroscopic level, the planet's rotation is a historical artifact, a fossil record of countless tiny interactions. Micro versus macro. At the micro level, deterministic equations. At the macro level, irreversible outcomes. You see this everywhere. Take a deck of cards. Visual, a perfectly ordered deck being shuffled. There is exactly one way to arrange a deck in perfect order. There is exactly one way to arrange a deck in perfect order. There are 52 factorial, that's 8 times 10, circumflex 67, disordered arrangements. If you shuffle, you will almost certainly get disorder. Venus's backward rotation might simply be the cosmic equivalent of a shuffled deck. Not forbidden. Just statistically rare. Why, and rare things happen when you have billions of years and billions of planets. Now here's the counter-argument. You might say, but physics should predict this precisely. We have equations. Yes, we do. But equations are only as good as the initial conditions you feed them. And here's Feynman's warning. We are very good at building beautiful models and very bad at admitting when nature doesn't care about our beauty. Planet formation is chaotic. Small differences amplify a tiny asymmetry in mass distribution. A slightly off-center impact of fluctuation in atmosphere density. Chaos theory tells us that in nonlinear systems, small changes grow exponentially, like weather. Can you predict the exact formation of a hurricane 5 years from now? Not because the laws are wrong, but because the laws are wrong. But because sensitivity to initial conditions makes long-term prediction impossible, Venus is a hurricane fossilized into planetary motion, and that should humble us. Because we often think of the universe as clockwork, but it's not, it's lawful. And that's different. Lawful means every step obeys equations. Clockwork means predictable. Chaos breaks predictability without breaking lawfulness. And this has philosophical consequences. You are made of atoms obeying time-symmetric laws. At the microscopic level, there is no preferred direction of time. And yet you experience an arrow of time. You age. You remember the past, not the future. Why, Tib? Because of entropy. Because of entropy. Because of entropy. Because statistically, disorder increases to Venus rotating backwards may be a monument to entropy's subtle power. Not dramatic. Just relentless probability sculpting the cosmos. And here's the beautiful part. If everything were perfectly predictable, if every planet spun neatly in the same direction at tidy speeds, the universe would be dull. Variation is the fingerprint of chaos, and chaos is the engine of creativity. Stars explode because of instabilities. Galaxies form because of fluctuations in the early universe. Life evolves because of random mutations filtered by selection, and Venus rotates backwards because sometimes in the cosmic shuffle you get a weird hand. You are alive because the universe is not tidy. Let me push this further. Suppose we did find a perfectly clean explanation tomorrow. A single impact, a precise tidal resonance, a neat equation that reproduces Venus exactly. Would that T remove the wonder? No, because beneath that explanation lies something deeper. Why do the laws allow this at all, this at all, this at all? Why do the laws allow this at all bid? Why is angular momentum conserved? Why do tidal forces dissipate energy other? Why does entropy increase? At some level we hit bedrock. The laws of physics say yes, or they say no. And we don't get to negotiate. Feynman loved that. He loved the idea that nature is under no obligation to make sense to us. And yet, astonishingly, it often does. We can launch spacecraft to Venus. Visual animation of spacecraft approaching Venus. We can measure its rotation to absurd precision. We can model atmospheric tides with supercomputers. Tiny primates on a rock around a star, calculating the motion of another world. That's insane. That's beautiful. Venus rotating backwards isn't a failure of science. It's a reminder of scale. The universe runs on simple rules applied relentlessly to enormous numbers of particles over unimaginable time. From that, complexity emerges. Sometimes elegance, sometimes weirdness, sometimes both. And here's the twist. In a few billion years, tidal forces will likely slow Earth too. Our days will lengthen. The moon will drift farther away. Eventually, Earth may become tidally locked to the sun if the sun doesn't engulf us first when it becomes a red giant. Nothing is permanent. Rotation isn't sacred. Order decays. Energy spreads. And yet, for a brief window, here we are, spinning at 1,670 kilometers per hour at the equator, orbiting at 30 kilometers per second, hurtling around the galaxy at 220 kilometers per second. And we feel still. Venus reminds us that motion is relative. Stability is temporary. History matters. At the atomic level, everything is collisions and fields. At the human level, it's sunrise and sunset. On Venus, sunrise comes from the wrong direction. But wrong compared to what? Compared to our expectations, Sal, and expectations are fragile things. So maybe the real lesson isn't about Venus at all. Maybe it's about humility. The universe does not owe us symmetry. It does not owe us simplicity. It does not owe us simplicity. It offers laws. And then it lets probability play. And from that dance, planets spin. Some forward, some backward. So the next time you watch a sunset, ask yourself, why does the sun move that way? Why does Earth spin as it does? What invisible hands, gravitational tugs, ancient impacts, molecular chaos, conspired to make your day 24 hours long? De-expectations. Venus rotates backwards. Not because the universe is broken, but because the universe is free within the boundaries of its laws to explore every allowed possibility. And we are lucky enough to witness it. Lucky enough to witness it. Lucky enough to be confused, because confusion is the beginning of understanding. So let me leave you with this. If a planet can quietly, slowly reverse its spin over billions of years, what other assumptions about reality are we holding that might someday flip? Tell me in the comments, what's one obvious truth about the universe that you suspect might be more fragile than it seems? And as always, stay curious.